Could we actually be living inside a black hole? A recent and unexpected discovery by the James Webb Space Telescope is sparking serious debate. Scientists from Kansas State University have released a groundbreaking study suggesting that certain cosmic structures may support a bold theory: our universe might exist within an enormous gravitational entity. But what exactly did the James Webb Telescope observe out there in the far reaches of space? And how could this be possible? After all, black holes are typically known for devouring everything in their path: matter, light, even time, creating chaos in their wake. Or is that the whole story? Perhaps not. Stick with us until the end, because you may just find out that you're watching this video from deep inside a cosmic giant. Let's rewind the clock, about 13.8 billion years. At the very beginning, there was nothing. Then, in a fraction of a second, the universe burst into existence in an event we now call the Big Bang. According to widely accepted scientific theories, all matter and radiation in the cosmos were once compressed into an unimaginably small point before expanding outward to form the universe as we know it. The original singularity underwent a dramatic expansion, giving rise to spacetime, the fundamental forces of physics, and all forms of matter. While the Big Bang theory is now a cornerstone of modern cosmology, it's important to remember that it's still a relatively recent concept. The idea first emerged in 1931, when Belgian priest and physicist Georges Lemaître, drawing on Edwin Hubble's groundbreaking discoveries, proposed that the universe is expanding, and therefore, must have once been much smaller. This led to the revolutionary notion that the entire cosmos may have originated from a single, incredibly dense point that exploded outward in what we now call the Big Bang. However, Lemaître's theory was not initially embraced by the scientific community. In fact, Albert Einstein reportedly dismissed it by saying Lemaître's grasp of physics was terrible. Even one of Lemaître's former professors at the University of Cambridge found the idea of a cosmic beginning deeply unsettling, calling it repugnant. At the time, the notion of a rigid, eternally unchanging universe was still firmly rooted in the minds of the leading figures in physics. Before Edwin Hubble's groundbreaking discovery, that there were other galaxies beyond the Milky Way, and that many were moving away from us, the Milky Way was believed to be the only galaxy in existence. Some opponents of the Big Bang theory were so resistant to this revolutionary shift that they tried to reconcile the new observations with the old beliefs. This led to the development of alternative theories, most notably the steady-state model proposed by British physicist Fred Hoyle. This theory, in keeping with the traditional view, suggested an eternal, infinite, and mostly unchanging universe. To explain the observed expansion, the model introduced the idea of a mysterious, invisible field that continuously creates new matter throughout space. In the end, the steady-state model couldn't withstand the test of real astronomical observations. By the 1960s, scientists noticed that radio galaxies and quasars only existed in the distant parts of the universe, not near the Milky Way. This indicated that such phenomena are linked to very old star clusters. But if the universe were truly unchanging, as the steady-state theory suggests, these active radio sources should appear evenly throughout space, not just in the farthest and oldest regions. The decisive blow to the steady-state theory came with the discovery of cosmic background radiation. This faint glow, a remnant from the early universe, remains one of the most compelling pieces of evidence supporting the Big Bang theory. Ironically, the name Big Bang was coined by Fred Hoyle, the very scientist who championed the steady-state model. In a 1949 radio interview, Hoyle mockingly referred to Georges Lemaître's idea as a theory where all matter was created in a Big Bang, clearly expressing his skepticism. Yet despite his criticism, the catchy phrase caught on, and it has remained ever since. The problems with the Big Bang. The Big Bang theory is widely accepted among mainstream scientists, yet it remains surrounded by major unanswered questions, some of which challenge our very understanding of reality. For instance, what caused something to suddenly appear from nothing 13.8 billion years ago? How can anything come from nothing? And what existed before the Big Bang? Many respected scientists argue that such questions are meaningless. Stephen Hawking once famously said, "The question of what came before the Big Bang is as meaningless as asking what lies north of the North Pole." Since time itself began with the Big Bang, the event couldn't have been triggered by anything or anyone. According to the laws of nature, the universe could have originated spontaneously, without energy, without cause. This means the true origin of the Big Bang is likely far beyond human comprehension. Still, not all researchers are satisfied with this explanation. As we hinted earlier, some believe that the answers to our cosmic mysteries may be found within black holes. But we'll explore that idea shortly. First, it's worth noting that a growing number of physicists now suspect that our universe may not be alone. Rather, it could be just one part of a vast multiverse, one tiny thread in an unimaginably large cosmic tapestry. The question of whether these worlds are interconnected remains a hot topic, especially in alternative physics communities. What we do know, however, is that each universe, no matter how strange, must have originated somehow. But how exactly? According to Nikodem Paplowski from the University of New Haven, there's little doubt, our universe may have been born from within a black hole. Could we actually be living inside one? And what has the James Webb Space Telescope uncovered that might support this idea? Paplowski's theory suggests that matter consumed by a black hole eventually reaches a limit, an ultimate point where it can no longer be compressed. This primordial seed, though unimaginably small, would carry a mass billions of times greater than our Sun. Due to the extreme rotation of black holes, which spin nearly at light speed, this seed undergoes tremendous torsional stress. It's not only compacted but also violently twisted, similar to a coiled toy snake just before it bursts out of a can. Eventually, the pressure may cause this seed to rupture, initiating the birth of an entirely new universe. But if that's the case, then black holes might act as one-way portals, cosmic gateways that can only be entered from one side. In theory, if someone were to fall into a black hole in the Milky Way, it's possible, though only a trace of their existence may remain, that they could emerge in another universe entirely. Our universe might actually be the offspring of a previous cosmos. According to one theory, the seed of our universe formed within a black hole in this parent universe. Roughly 13.8 billion years ago, it burst forth, what we know as the Big Bang, and has been expanding ever since. This opens up a bold possibility. We may still exist within the event horizon of that black hole. Fascinating as it sounds, this idea seems highly theoretical. So the key question becomes, is there any real evidence supporting such a mind-bending concept? Surprisingly, there might be. The James Webb Space Telescope has recently detected something that could lend weight to this astonishing theory. To understand it, we need to look at a study conducted by researchers at Kansas State University, led by Laura Shamir. The team analyzed 263 early galaxies located in a region known as the Jades Field, previously observed by Webb. What they discovered was an unexpected and puzzling pattern. The majority of these galaxies appeared to rotate in the same direction. Specifically, about 2/3 of them rotate clockwise, while only 1/3 spin the other way. But why does this uneven distribution of galactic rotation suggest we might be inside a black hole? Because it goes against what we would expect in a truly random universe. Statistically, galaxy rotations should be evenly split in both directions. This imbalance challenges our current understanding, and may point toward something far more extraordinary. Ultimately, there are two main interpretations of Webb's unexpected discovery. The first, and less thrilling, suggests that what we're seeing might simply be the result of measurement errors. Specifically, the Doppler effect could be making galaxies moving toward us appear brighter than those moving away, which might distort our observations. This could create the illusion that more galaxies are rotating in one direction than actually exist. But the second interpretation is far more fascinating. It proposes that our universe may have formed inside a rotating black hole. This aligns with what's known as Schwartz cosmology, which theorizes that our universe is essentially the interior of a black hole within a much larger mother universe. According to this view, Every black hole could give rise to its own baby universe, and the spin of the original black hole would influence the rotational direction of galaxies within that new universe.